we did 6.3 or 6.2, we learned that you take any type of equation and solve it, you're going to get a solution. So if we take and multiply through by 6, that's going to give us 3. 2, and then we distribute the 3 and the 2, and we get 3x minus 9 is equal to 2x minus 4. And the 2 comes over, that leaves us with x. The 9 goes over, that leaves us with 5. So x is equal to 5. Now what does that number do? X is equal to 5. What does it do to the equation? Say again. If you plug in that 5, what will it do? It'll make both sides what? Equal. And so it is the solution to this equation. So is this the only solution? Yes or no? Yes, it is. That is the only solution in our number system that will make that equation work. Now, it's important that you think about that before we go into inequalities, because inequalities, you have a set of numbers that work. This is the only number that will make this equation what? Equal to each side. Okay? And that's 6.2. Now the section we're going in today is a continuation of 6.2. You solve the problems the same way, especially if you keep your variable positive. When you keep your variable positive, everything's done the same way. So let's take a look at a simple example of 6.5. Somebody look and tell me if that's inequality. 6.6. Inequalities. Before we get started with inequalities, you've got to write down the following things. These two guys and these two guys. These two guys are represented by parentheses or an open circle. These two guys are represented by brackets or a closed circle. And what I mean by brackets and a closed circle. Anytime we give an answer to a solution set, that means more than one number, you have to use some kind of location on the number line and some kind of notation, interval notation or set builder notation. And we'll get to that in just a minute. So this is the only thing really that you have to learn that's new. Or it's not really new, but some of you haven't seen it in a while. Okay? And if you ask me in the next couple of days when we're going over problems, somebody's going to say, well, how did you know to do this? And I'm going to refer back to this. So you need to learn it. These two, they're not equal to. If they're not equal to, that means they don't touch the number or can't be located on a number line. This means right here, what does that mark right there mean? That means equal to or equal to. And that means that you do include that number, meaning if x is greater than or equal to 3, you do include 3 in the solution set, and you can locate 3 with a closed circle. That means you can use 3 or use that number. Well, let's take a look at this example. We used to do 2x plus 3 is equal to negative 3x plus 7. All right, that's what we used to do. This is an equality, and we solve it the same way. That negative 3 will come over and make 5x. That negative 3 will come over and be 4. And x is equal to 4/5. And as I said before on the previous problem, that is our only what? That's our only solution in our number system. The only number in the universe that will make these two sides equal. And again, that's 6 point whatever. 6.2. The only difference is now 2x plus 3 is equal to negative 3x plus 7. I'm going to take the equals out, and I'm going to put an equality there. Inequality there. Solve it the same way. The negative 3 comes over, that gives you 5x. Brings 3 across the river, that's the minus 3. 5x is greater than or equal to 4. X is greater than or equal to 4/5. Now, where this is just one solution to make this equal, this is a number of solutions that makes this true. This makes it equal. This makes this true. So, what is 4/5? 4/5 is close to 1, right? So, if x is greater than or equal to 1, the first thing I tell students to do, if you've ever been kind of shaky about inequalities, always graph it first. Always. So, go over here and you graph it. This arrowhead is called negative infinity. This arrowhead is called what? Positive infinity. It amazes me how many students don't know that. I guess it's not on some kind of test. 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Now, with this, how many location points are on this? Just one. Where is it? 4/5. So, I'm going to put this in red. X is equal to 4/5. 4/5 is almost 1. It's right there. I put a little dot right there. Now, did I make it little for a purpose? Yes. Because all that does is show where that 4/5 is located. Because that's the only solution to the problem. That's it. 4/5. That's it. But this says that all my answers, all my solutions for this problem is above what? Above or equal to what? So it's above or equal to, so I got to put a closed circle or a bracket if you wanted to. Brackets are usually used with notation. And then what numbers are greater than 4/5? To the right or to the left? To the right. So you shade these numbers. Now, that's nice and dandy, but we got to write it in some kind of notation. Because we got to hold our pinky up and be impressive at party. So we got to write it in some kind of notation, because that's basically what it comes down to. Because this is good enough for government work. This right here is an answer. I mean, that's the solution set. But we have to write it a little bit better. Now, there's two types of notation. There is no, you don't read the, you don't, that's a common mistake. I'm trying to draw things, you know, you guys can do this very well, do two things at one time, so just be much older than you. I want to delete that thing. And if you noticed, I'll tell y'all something. Did y'all notice when I wrote this, did I say less than or equal to or greater than or equal to? Or did I say these guys? I said these guys. Because you don't know what they are until you put numbers in. Well, I was always taught this is less than. No. You cannot. You can't say this is this or this is the other thing. You cannot do that because you don't know what's on this side and you don't know what's on this side. I could easily put, I could say this. 2 is greater than 1. I could say 1 is greater than 0. I could say 1 is less than 3. You see what I'm saying? Or I could say 3 is what? Greater than 1. If somebody tells you that one goes one way and the other one goes the other way, they're crazy because you don't know what's going to be on the side. I can say this is 3 is greater than 1, or I can say 1 is less than 3. What about this? 4 is greater than 5. I'm sorry, that's wrong. Duh. I meant to draw it the other way. 5 is greater than 4. Or 4 is what? Less than 5. So that debunks the little, if the alligator goes this way or if the alligator goes this way. Because I can say 4 is less than 5, or I can say 5 is greater than 4. Up here, I can say 1 is greater than 0, or 0 is less than 4. I can say 0 is less than 4 here, or 4 is greater than 0. You cannot pattern mathematics. It is a study of patterns. But you can't sit there and go, okay, well, it's this one's going to be this the whole time. No, it doesn't usually work that way. But to answer your question, that's why I do not say this is this, this is this, this is this, and this is this. I don't say that. I say these guys go with these, and these guys go with these. And then when you put it in a mathematical sentence, then you can say LT or GT, whichever one it is. It all depends on if you read from left to right or if you read right to left. That's what I'm going to say. Okay? Doesn't matter. And you have these teachers that say, oh, you can't do this. And if you take your kids from Salem to Iowa, Jody has to sit on the same side that he sat on the side. He can't sit on the other side of the system. That's what that teacher was saying. You can't put X on the right hand side. 4 is less than X, or X is what? Well, that's a same thing. So do not say greater than or less than unless you have something on each side of it. Because you don't know which one it is. You don't know which one it is. Think of a word that has 2 different meanings. Give me a word that has 2 different meanings.
Cold and
Huh?
hot. And hot.
No.
Same
Same word, 2 different meanings.
Present. Present.
Okay, well, that's a verb and a noun. Present, you are here, but if I just present, if I just say present, which context is it? You don't know unless I give you more what? Context. Context clues, context. They know English, they know 101. I can't just say, oh, well, that's this. present. Which president am I talking about? It's the same association. If you telling me that you know what this is, then you're telling me you already know what the sides are and you haven't even seen it. That's less than. Is it? Or is 5 greater than 4? 4 is less than 5. Yes, that's less than. What's that? You see what I'm saying? So don't. There's some things that I want you to patternize or memorize or whatever, but this is not one of them. Scientific notation is not one of them.
I like smack my high school teacher.
Well, it all depends on whether you were listening that day or not, too.
Oh, I was.
There's
oh,
two
okay.
sides to every
What's the problem?
sword, 2 edges to every sword. I'm not going to blame my high school teachers because I know how I was. Okay? Now, let's go back to the beginning. Right here. I'm going to erase this. You don't have to erase it. You can draw a line over here going to this. I'm going to add something else to it. There's 2 types. Well, you know, I'll just write it over here. 2 types of notation. There is set builder notation. I'll better write that out. I'm going to put a little bit simple. Set. And I like to say that set builder notation is really the pinky. Hold your pinky up. Because it's all you do is you take your answer and you put some braces around it. So it's really not that difficult. So let's say, well, a while ago we did a problem and we got x is greater than 4/5. Everybody agree with that? X is greater than or equal to 4/5. To write that in set builder notation, the only thing you do is put 2 braces and do this. X such that, and then write your answer. X is greater than or equal to 4/5. That's it. This X means that anywhere in this set where X is a variable, I'm going to use X such that X can be greater than or equal to a quantity of 4/5. That's what it means. Hold your pinky up. Because that is pretty much, so really you can take your highlighter Does this change? No, that doesn't change. The only thing that changes is what? The answer. So this is what you put in to set builder notation. Do I like set builder notation? I'd rather you use interval notation because interval notation stresses that you're reading the graph from left to what? Right. And that's what we're going to show you next. And it's called interval notation because it shows the solution set as an interval. Interval notation is where you're going to use these guys. So I'm going to take my handy dandy highlighter and purple or mauve, and I'm going to highlight this. I'm going to highlight this. Because that's where you use the parentheses and brackets. Now, I also put something right here. I'll put negative infinity and positive infinity, because can you touch infinity? No. So you can't touch, if you can't touch infinity, then parentheses go on infinity and negative infinity no matter what. Now let's go back to the problem we were doing right here. That's why graphing is so important. Because no matter what you say about yourself, a visual representation of the solution set will help you write the answer no matter what. So, which way do we read? Left to right. So we start from negative infinity, and we write down in interval notation when we hit the function, or when we hit the solution set, and when it ends. So our eyes start right here, negative infinity. And we go, 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 ding! Where do we hit the solution set? At where? 4/5. Do we use a parenthesis or a bracket at 4/5? Well, what do we have here? So what does that go with? Bracket. And we keep going to the solution set, we touching the solution set, we touching, and what do we go to? Positive infinity, and what goes on infinity? So the interval notation for this answer is from 4/5 to what? Infinity. Means 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 100/5, 100 over 5, 100/5, 200/5, keeps going. Any number over 4/5 or equal to 4/5 can be used to make this true. I didn't say equal, did I? I said true. So let's pick 5. We said that 4/5 was like 1 in the 5th, or close to 1. It's like a 7/8 inch wrench. It's close to 1. All right? So let's pick 5. 5. What's 2 times 5? 10 plus 3? 13. What's negative 3 times 5? Negative 15 plus 7 is negative 6 or negative 8? Is 13 greater than or equal to negative 8? Yes. And it'll work all day long. Put in 10. 23. Negative 23. Negative 23. Something like that. 23 is greater than or equal to negative 23. So, what do you need to do as a student to get these correct in 6.5? 1. Clear any fractions and decimals. And we didn't cover decimals. I need to cover those. Two, try to keep variable positive. Now there are 2 or 3 problems that you can't do it. And I'm going to show you how to do it with a negative variable. And that's the only time you will see me deal with a negative variable is when there's no other alternative. 3. And this is when you get the answer. Solve as 6.2. 4. The fourth is the most important part. Graph solution. That means on the what? No, on number line. I haven't said anything about a calculator. Why are you talking about a calculator? This is 6 and 4. 5. And once you graph your solution, put it in set builder notation and interval notation. And the reason you need to put it in both is so you can be used to both. I prefer interval notation, but that's just me. Now I want to cover a couple of problems out of the homework, and the reason I do is they have one in there that you cannot solve, that you cannot get the variable positive. So I want to make sure I cover that. So I'm going to pull up handy dandy homework, and y'all said this is 6.5. Okay, 6.6. Thank you. What are you being smart about? You just can't stand it, can you?
Okay.
You're just about to bust.
Oh, no. Really?
Mm-hmm.
I've heard that complaint lately, but
I know, you got to take it out on somebody, don't you? Did you tell Jessica that you were going to be the complaint department?
sure it is.
Okay.
She's pretty bad.
I don't blame her. There it is. No, that's a positive variable. Let's see if I can find a negative one. Nope. There we go. All right, I want you to make a note about this one. I want you to put this in your notes. I want you to highlight it. I want you to put stars around it, because this is the one that'll get you on the test if you're doing it the way I taught you. So I'm going to show you how to do it, because this is the only one that you won't see me try to make the variable positive, because there's no way to make it positive. If you notice, what do you notice about this problem? The variable is where? In the middle. So you really can't move it. It has to stay in the middle for your solution set. So the only thing to do here is divide through by -1. And if you do it on one side, you have to do it on all sides. But there's another rule that you have to remember when you have a negative variable. That if you divide or multiply through by a negative, you have to do what to the inequality? You have to flip them. That's why I don't teach a lot of that. Okay? I tell you to use it only as an emergency. And this is an emergency. So I'm going to divide through by -1 all the way through. So I'm going to write it out. -2 is greater than -x and greater than or equal to -6. And I'm going to divide through by -1, because that's a... Now what if that was -2x? What would you divide through by? -2. Okay, just want to make sure everybody understands that. Divide by -1, divide by -1, divide by -1. And as soon as you divide by -1, the next line, you're going to flip the what? Inequalities. So that would be a +2 less than x less than or equal to 6. And that is your solution set. Now this problem is a good problem that I picked, because there's two things I can show you here besides this. And the rule that I'm trying to show you, one rule that I'm trying to show you, if you multiply or divide through, you got to do all the way through, by a negative, you flip the inequalities. When you multiply or divide through by a negative, You have to flip the inequalities. When you flip them right at the last step, that's when you divide through. Right at the last step. Another thing that I would like to bring up here. The directions, and you got to look for this because I really don't care too much for these questions, but sometimes I'll accidentally put them on the test because I'm thinking they're the regular questions. Take a look at this. I'm going to put it in red. Right there. What does that say? Where x is a what? Integer. What is an integer? It's a 25-cent word for whole number. Okay? A regular 90% of the time question would say, graph the solution set of the inequalities where x is a number on the number line. And if it's a number, then you can have fractions, decimals, percents, and whole numbers. Mixed numbers. You can have anything you want. But since it says integers, an integer is a 25-cent word for whole number, you can't include what? Fractions, decimals, and percents. So which one of these are inclusive of fractions, decimals, and percents? Well, first of all, ask yourself, where are fractions, decimals? Where are they? Are they on top of the whole numbers? Are they between the whole numbers? Or what? Between. So which one of these number lines, there's several, which one of these number lines are showing just numbers? A. What else? There's more than one.
I can't see the numbers, so maybe that's why it's so quiet here.
No. I'm asking y'all, which one is including the fractions that's between the numbers?
I can't see it.
You can't see that blue, that dark blue line.
Yeah, I can see the dark blue line.
You don't have to worry about the numbers. You just have to worry about what is representative of A, B, and C. Why? Because they're shading between these numbers, which means they're including fractions, decimals, right in there. They're including fractions and the decimals. The dots are just the whole numbers. So that's why I want you to make a note of this. When you see that word, that means this is not right, this is not right, and this is not right. And of course, that's nothing. So it's going to be either this one or this one. What numbers are between 2 and 6? So your answer is right here. A lot of people say, Hubert, that says 3 and 6. Why does it say 3 and 6? Because this guy can include what? You can include 2. And that's why 2's in the top. So, I want you, this problem right here, there's two things that you need to realize. One is there will be one type of problem that you cannot make the variable positive, and this is it. And you divide through, and I would much rather you just divide through by negative on one problem than do it on 6 problems and forget half of the last 2 steps and miss 4 or 5 of 7 problems because you forgot. So just do that dividing through just for this type of problem with a negative.
And that makes the variable positive, right?
Yes. But before, you were making the variable positive by moving the biggest, the smallest bucket.
Right.
And that's the way you want to do it. But see, you can't do that right here because x is already by itself. The only thing you can do is divide through by negative.
Okay.
That's why. See, that'll give you another problem.
These are just main problems.
All right, let's do this one.
Well,
Blow it up. And these are real numbers, so you don't have to worry about the integer. It says, graph the solution set of the inequality where x is a real number, meaning fractions, decimals, and whole numbers. And hit freeze, please. I'm going to go ahead and call the roll. Miss Brown, Carrie, Dawson. I don't know how these pictures get on there. Dawson. No Dawson. Charles. Edwards. Elliott. Grubbs is here. Lee Croy. Littman is here. Pardue is here. Queen is here. Rochester is not here. Roebuck. Roebuck. No Roebuck. Satterfield. Shaw. Smith. Oh, got. I don't see either one of them. Nope, you're not here. Neither Smith is here. Miss Shaw, are you from, I may have already asked you this, are you from Star? No? Huh? Oh yeah, that's right, you're Brian and his brother. Yeah. Good. I already asked you, I know I asked you. Smith, okay. Vernon? Whitfield? Williford here. Wright? Okay. Bureaucrats are happy. All right, Vanna, bring it down, please, so I can draw on it. Or magnify, demagnify. All right, so here we go. This is a good test question. I'll be honest with you, I try not to put that last question on the test. I try not to. Sometimes it regenerates and pulls it in there, but I try not to do that. So, what we're going to do first, distribute. So that'd be 6x minus 12 is less than or equal to 6x minus what? Negative 6x, negative 6x, and what happens? The 6x is canceled and we get negative 12 is less than or equal to negative 14. True or false? Now be careful here, these are negatives. Ask yourself, what would you rather have in the bank? Negative 12 or negative 14? Negative 12. So negative 12 is what? Negative 12 is greater than or equal to negative 14. So is this a true statement? No, it's not. So if it's not true, it's called a contradiction. And a contradiction has no what? No solution. Sorry about that, that's not what I wanted. They don't have very good problems on this homework. Let me see if I can find some. It's kind of like interviewing somebody on TV and not giving them any hard questions. Let me go back. Let me go to the what is 6.5? Why I want to do 6.5 all the time? I don't even know what 6.5 is. Study plan. Let's see if I can find some problems in there. Evidently they watered it down. Yeah, they watered it down. Alright, we'll just do some. Alright, let's try this one. One half times x minus 3 plus 3/4 is greater than or equal to 2 times x minus 3 plus 1/2. Now that's a test question. What's the first thing you're going to do? Clear the fractions. After you quit for a while, get screwed.
Just do the question. So there's 2 halves, you just do like the 2 1/4.
The common denominator is 4. So you're going to multiply by 4 over 1. Is that your question? Yeah. So just put a 4 over 1 here, a 4 over 1 here, 4 over 1 here, 4 over 1 here. That should clean things up quite nicely. many of you know that it's pre-advising time? You need to get on, your advisor, get on Starfish, or they're on Starfish. I'm on Starfish. So you go to Get Connected. I'll show you how to get there. Just reminded me to remind, I'm trying to remind all my classes. Go to Get Connected. You go to, there we go. Faculty and staff. Go to Get Connected right there. And there it is right there. And when you go there, you need to go to up in here somewhere, appointments, somewhere in here, and you can find my appointments. I'm trying to find my appointments. Where are they? There they are. And see, you go in here and just click on add. Now, most of the teachers at Tri-County Tech are dinosaurs, right? So you'll have to go by the office and look on their wall or their door and sign up for a time. Or if they're one of the minority like me that's on, you just click on here and thing will fill it out and put your name. And the only thing we ask as advisors is that you don't come in there like a deadhead. That's the only thing we ask. Don't come in there, I'm here to register. Well, what are you going to have some idea, you know, of what, and if you don't have an idea, don't act stupid, okay? Just tell me you don't have any idea. Don't act stupid. I can't stand that. Okay? But that's how you do it. Is any of my advisees in here? Any? You don't know? If you don't know who your advisor is, you can go on your portal and find it. I think it's under, is it? Well, there's another one. I think it's under DegreeWorks, I know, but hold on a minute. Let me just see if I can find it. It was under Get Connected or Get Started or one of those also. Yeah, but somewhere in here it has your advisor or something like that. I think it's wherever you get. Where do y'all get your classes? Here it is. Identify my academic advisor. It's under Get Set. Identify my academic advisor. If you are a college transfer student and you want to change your advisor to the Anderson campus because most of your classes are here, you can dial 646 1428 and ask about your advisor or ask to change advisors. Now that's the college transfer. That's the associate arts, associate science. I don't think any of y'all, unless y'all are taking that one to the private sector. Most of y'all are either business and human services or health ed or IET or something, you know, that's not college transfer. But if you college transfer, you want to change your advisor or find out who your advisor is, you can dial that number. If you're somebody else, business and human services, you need to call that unit secretary or that division secretary wherever they are. I know business and human services is right in front of Pickens Hall, so work. Health ed, they're at the bottom of the big, ginormous building. What's it called? Bulk Hall, that desk down there. You can ask her. She'll probably give you the wrong one, but IE, they're down there somewhere in Cleveland. I don't know where they are. But anyway, that's just something for your information. Huh? They down there somewhere. I don't know where they are. They all over the place if you want the truth about it. All right, so here we go. What's 4 divided by 2? 2. Fours go out. 2. 2. And I think that's a whole lot easier to work with than that. 2x minus what? 6 plus 3. 2x minus 6 plus 2. These go out. And that leaves 3 is greater than what? Is that true? This is identity. So what's the answer? All real numbers. You're right. Thank you. Okay, now everybody's going to say, yeah, I got 8. Well, why didn't you say something back then?
Checking you.
Hey, my bad. And Bubba's on the back row going, yeah, man, you got it wrong. What'd I get wrong? Oh, all right, thank you. Shelley, you would have thought that. So let me start over. 2x minus 6 plus 3. I'm glad I made a mistake because I didn't want it to come out as an identity. I did it on purpose. 8x minus 24 plus 2. So 2x minus what? Minus 3. Greater than or equal to 8x minus 22. Okay, now here's what you were talking about a while ago with the negative x. You said we're keeping the variable positive. Well, at this point, you have a choice. You can either go, oh, well, we have to take the x over on the left-hand side, like my teacher told me in sixth grade, which is ludicrous. Or you can move the smallest bucket and keep the variable what? Positive. And I'm going to do it that way all the time. So negative 3 is greater than or equal to 6x minus 22. What are we going to do with that 22? Take it across the river and it becomes positive 22. And what's negative 3? You owe $3 and you have $22. You owe what? No, you don't owe. You have what? 19? I don't know. Somebody help me out. No. Is it? Yeah. Positive 19. So 19 is greater than or equal to 6x divided by 6. So x is less than or equal to 19.6. Or 19.6 is greater than or equal to x. And the reason I wanted to show you this was her question. When we had that problem, we got right here, and you have a choice. There's your two x's. Now you can take the 8x over on this side, but you have to remember 2 more steps at the end of the problem. Or you can bring this on this side and not have to remember those 2 steps. So it's nothing but a what? A preference. Now, I want you to graph this, and I want you to write it in set builder notation and interval notation. X is, let me just write it over here. X is less than or equal to 19.6. X is less than or equal to 19.6. Can you see that? Is that better? What is 16/9? 3? Pretty much. A lot of people say, oh, well, it's really a 2 point. No, listen. Are you getting right down to the nitty gritty and making sure each one of these is graduated into 6? Or are you just sketching? You're just sketching. Okay? You don't have to sit there and go, oh, well, 16 and going at 3 times, it'll be 3.07. And that's fine if they're asking for it, but if you're just sketching it, then just put it a little bit over 3. It's not that big a deal. So, 0, 1, 2, 3, 4, positive infinity, negative 1, negative 2, negative 3, negative 4, negative infinity. And we are at 3 and 1/6, which is 3.2. So what kind of circle goes here? Closed circle. I'll make it a little bit bigger. And my handy dandy shader. What numbers are less than 3? Or 3.16 or 3.17 or 3.2? Everything to what? So there's all your numbers that work in that equation. Now we just have to write it in set builder notation, which is real simple. This is how simple it is. Take that guy, copy it, draw big old braces, X such that, and then what? Well, it's simple when you don't have to do this. I know, but I'm doing it for y'all. So I really, you know. Huh? I know. I don't need y'all to tell me I need to be doing, okay? I need y'all to be quiet, all right? There. Alright. Now, what I was trying to show you is, all you gotta do is just look at it. Now, you're gonna fail. Alright, now, read from left to right. Do we hit the function here? Yes. From where? Negative infinity to what? To 19.6. What goes on infinity always? And what goes on 19.6? Yeah, simple it is. Before. Alright, let's try one. This time I'm going to kill 2 birds with 1 stone. We're going to go over a decimal problem because I didn't show y'all how to do that. And most of you probably already know, and that's fine, but let's go with 2.9 times x minus 1/2 is greater than 3.6 times x plus 4. Okay, decimals are just like parentheses. There's 2 ways to do them. 1, you can do them by hand, or 2, you can do them by calculator. And you know I'm not going to let you do a calculator because we already have too much of that now. So we're going to clear the fractions, and it's real simple. First thing you do is you note Rule 1. Note the furthest, if that's a word, put quotation marks, the furthest place value used. place value meaning to the right of the decimal. So in this case, what's the furthest place value you use? You have the 0.6 and the 0.9. You look at both the decimals. Sometimes it'd be 2.09 and 3.6. If it was 2.09 and 3.6, what is the furthest decimal place used? It'd be the hundredths. So you multiply by 100. Since this one is the same, what value is taken up? The tenth, so we multiply by 10. So 2 multiply through by tens, hundreds, thousands, etc., depending on number 1. Now, if you didn't know the trick about multiplying and dividing by tens, hundreds, and thousands, what's the rule? If you multiply by tens, hundreds, and thousands, you move the decimal place, however many zeros you have, you move it to the right that many places. If you divide by tens, hundreds, and thousands, you move the decimal place to the left, depending on how many zeros you're multiplying by. So in this case, we're multiplying by 10. Why am I multiplying by 10? Because that's the furthest place value taken. So I'm going to take my handy dandy red marker. And what will that do to these two decimals? Make them what? Whole numbers. So now we have 29 times x minus 1/2 greater than 36 times x plus 4. Now what? Huh? No, distribute. Don't look at that fraction unless you want to break your hand. Why can't I fool with that fraction? In concrete, you can't touch it. You got to break it up first. So 29x minus 29 halves greater than 36x plus 144. Somebody help me out. Now what we do? How do you do that? Multiply through by 2, which is the common denominator. I'm going to take my handy dandy red pencil again. Multiply by 2 over 1, all the way through. What's 2 times 29? 58. What happens to the 2 with the 2 over 29, or 29 over 2? Cancels. 36 times 2, 72. And 288. Now which one's the bigger bucket? I'm sorry, the smaller bucket. 58 goes across. Negative 29 is greater than 72 minus 58, dang old 14. Huh? Is it 14? I think so. Thank you for checking for us. Check 288 where? Cross. And 288, that's going to be minus. In other words, that's going to be 317. Somebody help me out. Negative 317 is greater than 14x. Now get your calculators out. You don't really have to. 14 will go in there twice. That'll be 28, 37. 14, 3 times maybe? No, 2 times. So 22. I don't know what that leaves. That leaves 28. 28 against 37. I'll leave 9. 90, 90, 90, 90, let's see, 5, 6, 7, 7, 6. 22.6, what do you get? This is mirror. So 22.6 is greater than x, or x is what? Less than 22.6. So graph it. Graph it and do what you need to do. Interval notation, set filter notation. I'm class over Mr. Lewis, but I trust you. Okay. There's some people in here I don't trust. Y'all tell me it's over 2 o'clock. What, Michelle?
What?
Nothing. X is less than 22.6. Now, if your time is getting you 0, 23, 23, infinity, negative infinity. What goes on 26 or 22.6? Open circle. 22.6 is right in here. Now, when I do an open circle, I usually erase the inside. But I like to tell students it's like a bubble. In other words, it's like a little force field. You can't touch it. No. There. And what numbers are less than 23? Everything to the left. There. Today's just not my day. Now, I'll try this again. Bracket. I got my clipboard over here now. All right. Now read it from left to right. What we're going to hit first? Negative infinity. 2, 23 over 22.6. And what goes on both of them? Now tell me what's hard about that. Yeah, that's some real hard math there.
Your smartboard technique.
Well, we've had these things since I left, at least 5 or 6 years, and I just, let me put it to you this way. They're good, but they're not exactly there yet. And then these are old, so they've probably gotten a whole lot better. All right, y'all get out of here. Have a good day. Somebody hit my button for me. Thanks, Vanna.